A-Level Computer Science 9618 paper 2, and this is part 7. And today in this video we are going to discuss about we will be focusing on the structure, on the charts, flow charts, state transition diagrams, and structure diagram. Okay, we will be focusing on the diagrams. So let's start with structured diagram. Okay, so what is a structured diagram? It's a diagram that defines the relation. It tells us about the passing of parameter between module, or you can call it subroutines. Okay, this is what it shows interface. A structured a structured chart shows the interface. A structured chart shows the interface between modules and variables. Between, you can call it subroutine as well, subroutine functions or procedures. Okay, these variables refer to as parameters. Supplying a value to the lower level module is shown as downward pointing arrow. A parameter supplying a new value to the module at the next higher level is shown as the upward. Okay, so this is a structured chart and it's showing three subroutines. Okay, so these three are subroutines, and this is the main subroutine, and inside this contain these two subroutine. I mean all of them are made differently. I mean, look, there are three functions. So in this function, two of these functions are been called in here. Okay, so this is known as a conditional statements. Okay, these are the passing of parameters. Yeah, so this is a function item process, and it's passing the parameter in string to this function. After going in here, and then it will try to calculate, and then it will return the boolean red flag to this. Okay, so that's the relationship between these two subroutines. And as for this, it's also passing in string to this one, and it doesn't return anything. It says remove from list. So these two are functions, and this is the code. So the structure chart shows interface between modules. So subroutine, the variables, passing variables between these subroutines. These variables are referred to as parameters. Supplying a value to a lower level module is shown as downward pointing arrow. Okay, you don't need to understand this. What you need to know that this is how you represent. You are passing a parameter. This is how you represent it. Passing a parameter. Either it is integer or any kind of variable, integer, string, char, anything except boolean. So you are passing a parameter. But if you are passing a boolean value, then this is how you represent this arrow. When you are passing a boolean value, this is how you represent this, passing a boolean. But when you're not passing a boolean, you're passing integers, string, or any other data type except boolean, then you will represent in this way. Okay, so this is passing boolean. An arrow with a solid round end shows that the value transferred is a flag, a boolean value. A double-headed arrow shows that the variable value is updated. So if the variable is being updated, this is how you try to show. This is how you show. Okay, within the modules, a variable value is updated within the module. This is how you try to show it. So this is the code. This is the pseudocode. This is the function item process. Then it's passing having a parameter add item and in string, and returning a boolean. Okay, don't understand this. Declare red flag is equals to false. If add item is equal to yes, then red flag is equal to add to toilet in string. Okay, so you're passing a parameter in string into this function add to list. This add to list, you're passing this. Okay, this is how you try to show the relationship between these subroutines. Okay, this is a function actually, and this is a procedure. If then, okay, so there's a if then statement. So this is how you try to represent in triangle form. Okay, if this, then this, else this, and if return red flag and function. Okay, so this is how you try to show in structured chart. So dim num1 take as integer, console or write line. Okay, this is the main. This is another procedure. This is a subroutine. This is a procedure. Okay, so let's count, or you can call it, this is a main. So you're trying to count something. Let's count Num1 is equals to, if take is equal to take plus 1 and count num1. Okay, so you're passing this parameter, you can call it parameter. So you're passing num1, it's also been updated as well. Since it's been updated, that's why you're going to show in this way, that you're passing num1 in here, and the countdown, well, it doesn't return anything, but it definitely using by reference, so it will change the value of the variable. So okay, so it's been updated. And if you want to put a loop, then this how you put a loop, you put like this, telling that there's a loop. Okay, so yeah, let's move on. Here's another example. Average input numbers calculate average output average. So average, okay, so this is might be the function. And okay, input numbers, so this is giving these two parameters, which means so okay, these are procedures. So again, there's a function output average calculate average, and this is input number. Even though you can I could have just put in make it in a form of a procedure, but I didn't do it. But still I can do that. Okay, don't worry about it, I can do that. So putting in this in a form of procedure, like sub input numbers, and without passing anything, I'm just uh, I'm giving something actually. Yeah, so num1 is equals to this, num2 is equals to this, so I'm giving the values, and then these value will be given to this function calculate average. So num1 num2 is coming here, and then it goes here. So num1 and num2 came here, and then it's going in here, this is the direction, and then this will return an average. So yeah, it returned an average. Okay, the average. Okay, and then this average will come in here, it passed into here, output average, and there you go, output average. Okay, so these are function, you can call it modules, are the relationship between these modules. If I were, I could have made 4 different subroutines. Okay, this one different, this one is different, this one is different, this one is different. I could have put like procedure average. Okay, and then inside it I'm calling input num. I'm doing this I may have the global variables like num1 and num2 in order to change their values, num1 and num2. Okay, then I could have just passed it into calculate average, and then it will return average, and then this variable will pass to here, like something like that. Okay, it's not very difficult. So this is example 1, and in example 2. Okay, again there are at least 1 2 3 4 5, and here it's, yeah, this is a conditional statement. Okay, so input any number, supposing that this is a global variable, and I'm just giving an input, and then this come here and it goes here. There you go, num1 is gone here. Okay, now it will check it, divide by 3 or add, and it might print something actually. Okay, then it's okay. So there are 3 variables being passed, num1 has been passed, total has been passed, and count has been passed. Total and count is been updated, so it's coming here, and then count parameter has been passed to here. Let's see the code. Okay, so let's start from here, input any numbers. So yeah, this is input any number, starting from here. While number is greater than 0, check number. This is another procedure, another subroutine. Check number, this is the check number, and I have passed num1, count, and total. So num1, count, and total I have passed. Okay, so check number, here you go, and I have done by reference. Okay, so what am I changing? I am changing the count value. I'm changing the, okay, so this is another function or a subroutine, and these subroutine are here. Okay, So if I've called div by 3, okay, I'm passing a count. So I could just show it like this, that this is the count variable being passed, count. And as for the add, I'm passing num1 and total in here. I'm passing num1 and total. Okay, and I'm changing I'm giving back the value, which means I can put this in this way, because the count variable is being changed. I'm giving I'm giving count, and it's returning the value count. So it is updating the variable. Okay, and as for this one, n1 and t, I'm giving num1 and total, but I'm updating the total. So this will be updated. So I have shown in here actually. It's though both of these have been updated, and this one has been passed only. Okay, and yeah, that's it. And then I have this output the multiple of 3. So output the multiple of 3. I could have put this in in another procedure, like procedure output, and then I would have put this code in here, and then I would have passed this as an argument into this procedure, but I didn't do that. Yeah, even though it is possible to do it, you can do that. Okay, so this would be in a different procedure, and then I would be passing this argument as a parameter of that, and then it will give an output. Okay, so this is example 2. Okay, and I have also put a loop in here that's telling that this could be a while loop, a for loop, or repeat loop, any kind of loop. Okay, so I have put a loop in here, which means starting from here, the loop has been put in. Okay, this loop is for check number. That's why it's crossing from here to here. If it would have been for all of these subroutine, the loop, if this loop was for all of these subroutine, then it would have been written down like this, but it didn't. So this loop is for only this one, for this subroutine. Okay, so as you can see here, and this is the subroutine check number. So this is example 2, and in example 3, this is a part of this is a past paper. Okay, so structure diagram example 3, and you got these three subroutines. Okay, so you got a fourth. Okay, so this is lookup, update, validate, lookup, update, and you got the fourth module. It calls the 3 module in the following sequence. Okay, so this is the fourth module. It's showing how there's a relationship. So validate is taking, okay, so it's taking p4, it's taking p3 and s2. Validate is taking s2 and p3. Okay, and it is returning boolean, so it will return boolean. Lookup is taking p4 and m4, okay, it's changing the value m4. And update is taking t4 and returns integer. So this is the integer, this is taking t4. So it's really easy. It's really not that difficult. So you can call it module or subroutine. So structured diagram only shows the relationship between the subroutine, or module, you can call it subroutine. Okay, so now we have state transition diagram. So structure chart is complete. We have come to state transition diagram. A finished state machine, FSM, a machine that consists of a fixed set of possible state with a set of input that change the state and a set of possible output. State transition table that gives information about the state of an FSM. Okay, A computer system can be seen as a finite state machine. F has a start state. It has a start state. What is the transformation from one state to another state? A state of FSM can be represented in state transition diagram. A diagram that describes the behavior of an FSM. Okay, so state transition diagram tells us about. It tells us that, for example, let's say that I have a bulb. For example, I have a bulb, okay, and it's glowing. How many ways are there to on this bulb, to make this bulb being on? Either I on the switch, or there is electricity. Okay, let me make a state transition diagram for you. For example, the bulb is on. So how it is on? Either I have on the switch, or electricity is going. Okay, and if the bulb is off, then it means that I have off the switch. The switch is off the switch. Or it could be possible that electricity is not flowing in here. Electricity is going, electricity is not flowing. Okay, what happens if I on the switch? Even though the bulb is on, but I'm I'm pressing the on button of the switch. It will remain on. Okay, yeah, so if I on the switch, it will remain on. And the same thing here, that if I press off the switch, then it will remain off. It won't change anything. So these are states, and you can call it change in state by doing actions. Like if I press the off button, then it will become off. The bulb is off. If I press the on switch, then it will become on. And there are some there are some other ways as well. Like if electricity is going, then if I put on the switch, then the bulb is on. Okay, so this is how you try to make a state transition diagram. So for example, I have this example. A turnstile is a gate which is in a lock state. To open it and pass through, a customer insert a coin into a slot on the turnstile. The turnstile then unlocks and allows the customer to push the turnstile and pass through the gate. After the customer has passed through, the turnstile locked again. If a customer pushes the turnstile while it is in locked mode, it will remain locked until another coin is inserted. The turnstile has two possible states, locked and unlocked. Okay, so these are two possible states. The transition from one state to another is shown in the table. The table has been given, and then we have been given this diagram. So right now the turnstile is locked. If I push, then it will remain locked. It won't change anything, and I'm starting from here. But if I insert a coin, it will be unlocked. And even if I attempt to insert a coin, it will remain unlocked. And then if I pass through, it will become locked. So these are two states. State 1, state 2. Okay, and these are actions. These are actions for changing the states. Okay, so this is the state transition diagram. Now let's move on to flowchart. What is a flowchart? It is a graphic representations of the individual step or actions to implement a particular module. Okay, a graphic representation of the individual step or action to implement a particular module. Flowchart can be likened to the blueprint of a building. Actually, flowchart or pseudocode both are very similar, both have the same goal of determining what the code will look like, how the code will perform, how the code will run. It's just the only difference between pseudocode and flowchart is that flowchart is in a diagram way, in a diagram version. It's in graphical way, and pseudocode is in text, it's in written form. That's the difference. So let's see the symbols. We try to show the direction that where the data is flowing or logical solutions. So in this way, this is a start or end. So whenever we try to make a flowchart, we will just start. We will make this like start, and then it will keep on going, and then end. Okay, this is how you start. This is used for assignment, for assigning values, like for example c is equals to 1 0, or c is equals to c plus 1. Incrementing initialize variable, declaring variables, like declare num as string, num as integer. Okay, so you are using this for declaring. This is used for input, output, or any processing work. Sorry, this only for input and output. Okay, like input num, then I'll put in this way. Okay, output num. Yeah, conditional statement, if then else, or this is if then else. Okay, making decision true or false based on condition. For example, no, yes. Okay, like this. So this is used for conditional statement, if then else, and case of otherwise, like that. This diagram is used for this shape is used for when, for example, you have this page, right? This is page 1, and you are starting doing flowchart, and you are reached the end of the page, so you're going to make this, and then you'll make this, and then you keep on starting, you keep on going. So connection of flowchart on the same page, but as for this one, you are making a connection for flowchart from page to page, from one page to another. For example, this page is done, so now you're going to make this circle, and then you go to the second page, and it will keep on continuing. Okay, it will keep on continuing. Okay, so these are the shapes for flowchart. And now let's start. For example, you have been given a question to draw a flowchart for a program that read two numbers. The first numbers represent the unit price of a product, and the second number represent the quantity of the product sold. Calculate and print the total size, the total sale. So the first number represent the unit price of a product, and the second number represent the quantity of the product sold. Calculate the print cell. So you're going to declare them. First of all, you're going to declare them before taking an input. You will going to declare it. Like for example, you will like start like this, start, then declare unit price as integer, declare quantity as integer, and you're going to make a rectangle. Okay, then you will take an input. You can put in one box like input unit price, input quantity. Okay, this is how you're going to take it. So it will look like this. Okay, then you will start from there. Okay, this is how it will look like. There you go. So start, then you're declaring these variables, then you're going to take input, and then you need another declaration. Declare total sale as integer. Okay, so you have declared it. It will be in the box as well, so it will look like this. Okay, then total is unit parameter quantity, and then you give an output and then end. This is flowchart. Second question, draw a flowchart to find the sum of the first 50 natural numbers. So you start, then you're going to declare this, declare sum as integer, declare n as integer, then you can just sum is equal to 0. Wait, put it in a different box. So this will be there, this will be there, it will be there. So it will start from here, and then yeah, then it will start from here. N is equal to n plus 1, sum plus 1. Is sum is equal to 50? No, go back. This is a loop. This is how you're putting a loop. Is you are incrementing it, right? So if n, the value of n is equal to 50, then it will continue as it will go back. Keep on doing. Sum is equal to plus 1 plus 1 plus 1, and if it is 50, then yes, output sum and the program. Okay, this is the example of case of otherwise. This is the algorithm. Case of Meticor, if it is F, then this will run. If it is B, then this will run. K, if this one E, otherwise process error. End of case. And this is how you making it. Okay, injury detection. Case of Meticor, if it is F, then this will run. If it is B, this will run. If it is K, this will run. If it is E, if this will run. Else, otherwise error. Okay, this symbol that you can see here is a function, is a subroutine. Okay, if you can make this you can make this, I haven't made this. This is a subroutine, so I'm making another one. Subroutine, that you're calling a subroutine, calling a procedure, calling a function. Okay, then we have another question, draw a flowchart to find the large of the three numbers ABC. So declare A as integer, declare B as integer, declare C as integer, then input A, B, C, and then you will try to compare using this Ruby form shape. Okay, so input ABC, is A is greater than B? Yes. If A is greater than C, yes, then this is the answer. Print A. It is the largest. If it is greater than C, no. Print C. Is A greater than B? No. Is B greater than C? No. Then print B. So this is how you make it. Drawing a flowchart to find the largest of the three numbers ABC. This is another flowchart. If pay time is equals to hourly, if it is true, is, instead of if, it should be is pay time is equals to hourly, is okay. Is pay time is equal to hourly? True, yes. Is hour is greater than 40? True, this, then it will come here. False, this, come here. False, this, and it will come here. So this is start, this is end, and this isn't how you try to. Okay, you know what, just neglect this. Actually it will be like this. Okay, so end, start, that's it. Start, end. Okay, so this is how you make a flowchart. No, not much of a difference between a pseudocode and a flowchart, and that's